Hello everybody, and once again welcome to Pankaj Restaurant Tutorials. And today in this session we are going to deal with international mathematics, as you can see on the screen. And this is for the IGCSE 10th grade students, and the topic is matrices and transformations. And I am going to use the David Reyner book textbook, which is the 4th edition that I'm using. And as you can recollect that I was doing exercise 2, and in this exercise 2 I have already covered up to question number 10. So today in continuation I'm going to start with question number 11. So let us get started. Question number 11 says that, and let me tell you, this question number 1 to 15 in this exercise 2 are all dealing with the inverse of a matrix. So you have to find out the inverse of a matrix. So matrix will be given to you. You are supposed to find out the inverse of that matrix. Okay. So question number 11, the matrix given is 3 minus 2 and 1 and 4. Okay. So this is the matrix given to you. Let this matrix be A. Okay. So the question asked is you have to find out what is A inverse, right? So to find out what is A inverse, first of all, you will have to find out what is the determinant of A. So determinant of A will be equal to, now 4 into 3 is 12 minus, minus 2 into 1 is minus 2. So it happens to be 12 plus 2, that is 14. Now this 14 is not equal to 0, and because determinant of A is not equal to 0, therefore we can say that inverse of A exists. Okay. Now, second thing that you have to find out is the adjoint of this matrix A. Adjoint of this matrix A. Okay. Now, how to find the adjoint of this matrix A? I have taught you the shortcut method of finding the adjoint of this matrix. So what you have to do is you have to swipe the position of this 3 and 4. So you will get this here 4 and 3 over here. You have to just interchange the position of this 3 and 4 on this principal diagonal. Okay. So that I did it 4 and 3. And on this diagonal, whatever elements you have, there you have to just change the sign. Okay. So this is minus 2. So make it plus 2, and this is 1, so make it minus 1, right? So with these two steps you get the adjoint of this matrix A. Once you get the adjoint of this matrix A, once you get the determinant of this matrix A, you can use this formula: A inverse is equal to 1 upon determinant of A times the adjoint of the matrix A. Okay, now this is the formula. Now using this formula you will get 1 upon 14, because 14 is the determinant value of this matrix A, times the adjoint, that is 4, 2, minus 1 and 3. So this is your answer: 1 by 14 times 4, 2, minus 1, 3. Now let me check the answer behind and confirm whether it is correct or not. So the answer is 11th ka answer is 1 upon 14 times 4, 2, minus 1, 3. So this is absolutely correct. Okay. So question number 11 is done with. Now let us move on to question number 12. Question number 12 says that suppose you have a matrix B which is given by, okay, minus 3 and a 1, 2 and a 1. Okay. You are supposed to find out now B inverse. So determinant of B will be equal to minus 3 into 1 is minus 3, minus 2 into 1 is 2. This happens to be minus 3 minus 2, which is equal to a minus 5. Okay. Now this minus 5 is not equal to 0. Therefore, determinant of B not equal to 0 implies that B inverse exists. Now let us try to find out the adjoint of this matrix B. So by shortcut method, the adjoint of this matrix B will be, I'll swipe these two elements in this principal diagonal and I'll make this 1 and minus 3. And on this diagonal, the elements, I'll change the sign only. So this will become minus 1 and minus 2. So this is my adjoint. This is my determinant of matrix B. So B inverse, by formula, it will be 1 upon determinant of B, which is minus 5, times the adjoint of the B, which is 1, minus 1, minus 2 and minus 3. So this happens to be the answer for question number 12. Now let me check the answer behind to confirm whether it is correct or not. And question number 12, the answer is yes, minus 1 upon 5 times 1 minus 1 minus 2 minus 3. So this is absolutely correct. Now question number 13. Question number 13 says that suppose you have a matrix A given by it's a 2 and a minus 3, and then it's a 1 and a minus 4. Okay. Now you have to find out A inverse, right? So again, determinant of A will be equal to 4 2s are 8, so minus 8 minus, this is 3 into minus 3 into 1 is minus 3. This happens to be minus 8 plus 3, which is equal to a minus 5. Okay. Now this is not equal to 0, therefore A inverse exists. Now let us try to find out the adjoint of this matrix A. This will be given by swiping these two positions of the elements 2 and minus 4. So this will become minus 4 and a 2, and just change the sign of these two elements. So this will become 3 and minus 1. This is the adjoint, this is the determinant. So A inverse will be equal to 1 upon determinant of A, that is minus 5. So minus 1 by 5 times the adjoint, that is minus 4, 3, minus 1 and 2. This is the answer for A inverse. And let us check the answer for this. And the answer for the 13th one is minus 1 by 5 times minus 4, 3, minus 1 and a 2. So it's absolutely correct. Okay. Now, let us go for question number 14. Question number 14. Let the matrix B be equal to 7, 0, minus 5 and a 1. Now, you have to find out B inverse. So start with determinant of B. Determinant of B will be equal to 7 into 1 is 7 minus 5 into 0 will be 0. This is nothing but 7 minus 0, which is equal to 7. This is not equal to 0. Therefore, since determinant of B is not equal to 0, we can say that B inverse exists. Now let us find out the adjoint of the matrix B. The adjoint of the matrix B by shortcut method will be this 1 and 7. I'll swipe the position and write it as 1 and 7. And here 0, because 0 is not having either a positive or a negative sign, so no need of changing any sign, just write a 0 over here. And here you have to change the sign from minus 5 to plus 5. So this is the adjoint of the matrix B. This is the determinant of the matrix B. So B inverse will be equal to 1 upon determinant of B, which is 7, times the adjoint of B, which is 1, 0, 5 and then 7. So this has to be the answer. And let me check the answer and verify. Question number 14 ka answer is 1 by 7 times 1057, which is absolutely correct. So moving on to question number 15. Question number 15 says that suppose we have a matrix A, okay, and it is like say 2, 1, minus 2 and a minus 4. Okay. Now you have to find out what is A inverse. Okay. So first of all, determinant of A will be equal to minus 4 into 2 will be minus 8, minus 2 into 1 will be minus 2. This happens to be minus 8 plus a 2. This happens to be minus 6. So determinant of A is not equal to 0. Therefore, we can say A inverse exists. Now let us try to find out the adjoint of this matrix A. So adjoint of this matrix A can be found out by the shortcut method, like minus 4 and a 2 over here. I have swiped the two elements over here on this principal diagonal, and these elements I'm going to change the sign to minus 1 and 2. That's it. So this is the adjoint of this matrix A, and this is the determinant of this matrix A. So A inverse will be equal to 1 upon determinant of matrix A, that is minus 6, times the adjoint, that is minus 4, minus 1, 2 and a 2. So this should be the answer for A inverse. So let us check the answer for 15th. And the question number 15th answer is minus 1 by 6 times minus 4, minus 1, 2 and a 2. So this is absolutely correct. Okay. So that was question number 15. Let us move on to question number 16. Now question number 16 onwards, the question is going to be different. Okay, the questions are going to be different. Question number 16 says that if B is a matrix given by 2, 4, 1 and 3, okay, and AB is equal to I, you have to find out A. Okay, find out A. So this is the question. So matrix B is given to you and AB is equal to I is also given to you. Okay, you have to find out what is the matrix A. Okay, now here how to do this question. Now here, since this AB is equal to I is given, this is given to you. Okay, and matrix A is also given to you. Sorry, matrix B is also given to you. It is 2, 4, 1 and 3. This is matrix B. And here you will have a matrix A. Okay, so matrix A will be, say, A, B, C, D. Okay, this is equal to identity matrix, which is 1, 0, 0, 1. Okay, fine. Now what happens, this is the equation. Okay, now one more thing you should understand, this AB is equal to I is given to you. That means this A, this B will be equal to, or rather A will be equal to, or let me do this way. Okay, I will multiply out A inverse, sorry, B inverse. This is A, B. Okay, I'll multiply with this B inverse over here, and here also I'll do that, I into B inverse. Okay, now this B into B inverse is nothing but A into I. Okay, so A into I, because we know that any matrix B multiplied by its inverse should give you I. Okay, this is the reason for this. So I'll get A into I equal to I into B inverse, isn't it? Right? Okay. Now A into I is nothing but A, because I is an identity matrix, and identity matrix multiplied by any matrix, for example A into this identity matrix I, will give you the same matrix A. So I'll get A into I as A. A will be equal to I into B inverse. Now I will be nothing but 1, 0, 0, 1 identity matrix, and this B inverse is something that I will have to find out. Okay, now how can I find out the B inverse? The B is given to me, matrix B is given to me. So from this matrix B I am going to find out B inverse, and then I am going to multiply this B inverse and this identity matrix, and whatever answer I get, that will be the answer for this A. That is how I will get the answer for this matrix A. So this is the strategy that I'm going to use. Okay, so now my target is to find out B inverse. Okay, so B inverse will be what? B inverse will be equal to 1 upon determinant of B multiplied by adjoint of the matrix B. This is the formula. Okay, now what will be the determinant of B? So I'll directly find out from here. Now because B is given to me as this one. Okay, 2, 4, 1, 3. So determinant of B will be equal to, I'll write here, it will be 3 2s are 6 minus 4 1s are 4. This happens to be 6 minus 4, which is 2. So I'll get 1 upon 2 over here. Now what will be the adjoint of this B? Adjoint of the B will be equal to, adjoint of B will be equal to, now I will swipe the position of 2 and 3, and I'll write here 3 and 2 this way, and this 4 and 1 I'm just going to change the sign, minus 4 and minus 1. So this is the adjoint. Okay, so my B inverse will be 1 upon determinant of B, that is 1 upon 2, multiplied by adjoint of B. So adjoint of B is 3 it's 3 minus 4 minus 1 and a 2. Now what I'll have to do is this half I'll have to take inside. Okay, so I'll have to do scalar multiplication. So this happens to be 3 by 2. This is minus 4 by 2, that is minus 2. This is minus 1 by 2. And this is 2 by 2, that is 1. Okay. Now this is my B inverse. Okay. Now, if I want to find out this A, so A will be equal to this identity matrix 1, 0, 0, 1 times B inverse. B inverse is 3 by 2 minus 2 minus half and a 1. Okay. So if you multiply this out, you should get the same thing. Okay. Now let us do that. This multiplication will be first row and first column will multiply out first. So this will be 3 by 2 times 1, 3 by 2 plus 0. So that will be 3 by 2 only. Then here I'll get the first row and second column. So minus 2 into 1 is minus 2 plus 1 into 0 is 1. So that is minus 2 plus 0 minus 2. Here I will get the second row into first column. That is 0 into 3 by 2 is 0. And then 1 into minus 1 by 2 is just minus 1 by 2. 0 plus minus 1 by 2 is minus 1 by 2. And here I will get this second row and the second column, which is 1 into minus 2, that is minus 2 plus, 0 into minus 2, that is 0. And 1 into 1 is 1. So I'll get this 1 over here. Okay. Now you can see here, I'm getting the same thing. Okay. That is, this is what I'm getting repeated here. Now this is why, because any matrix multiplied by identity matrix, Bi multiplied by B inverse will give me what? This B inverse only, isn't it? So I am getting this identity matrix multiplied by B inverse. The answer will be B inverse only. Okay. So basically my A is nothing but B inverse. Okay. So my answer will be A matrix will be 3 by 2 minus 2 minus half and a 1. This is the answer for this question number 16. Let us check the answer behind and verify whether it is correct or not. And question number 16 ka answer behind is given as okay, you know, behind the book the answer is given as A is equal to 1 by 2 times 3 and a minus 4 and a minus 1 and a 2. Now this answer is the same as this one. Okay, now let us take this inside 1 by 2. So this will become 1 by 2 times 3 will be 3 by 2, which we are getting. Then minus 4 upon 2 will be minus 2, which we are getting here. And this minus 1 by 2 and minus 1 by 2 into minus 1 by 2 will be minus 1. Okay, so I mean minus 1 by 2. 1 by 2 into minus 1 will be minus 1 by 2, and this will become 1. Okay. So can you see this and this answer both are same? So in the book behind, this is the answer that is given, which is same as this one that we got. Okay. So nothing wrong with our answer. So our answer is correct. So matrix A will be equal to 3 by 2 minus 2 minus half and a 1, or 1 by 2 times 3 minus 4 minus 1 and a 2. That was question number 16. Now let us go on to question number 17. Question number 17 is this one. Find y if y times minus 2, 0, 3 and a 1 is equal to 1, 0, 0, 1. Okay. So you have to find out the matrix y if this is given to you. Okay. Now here you can see that y is a matrix multiplied by this minus 2, 0, 3 and 1 is giving you this identity matrix I, isn't it? Now you know that y multiplied by y inverse will be equal to I. Okay. Therefore, comparing this 1 and 2, can you say that this y inverse will be nothing but uh, minus 2, 0, 3 and 1. Okay. Y inverse will be this minus 2, 0, 3 and 1. Okay. Now, if you want to find out y, okay, what you will do? So, to find out y, what you will do is Okay, now this is y inverse is equal to I want now I want to find out what is y, isn't it? So what I will do is to find out y. Okay. Hmm. Now y inverse is this. Okay, so from this y inverse, if I want to find out y, what should I do? Okay, so if I multiply this out by y inverse into y inverse will be equal to y inverse into I. See what I did? In this equation, I have multiplied on the left hand side by y inverse. Okay, so now what will happen? This y inverse into y, this will become I. No, I want what? Y I want, right? So y will be equal to what? Okay, so this will be y inverse into I will be y inverse. And this will be, okay, now this is a bit tricky one. Okay, so let us try to do this way. So here, what we will do is let this particular matrix minus 2, 0, 3, 1 be x. Okay, so can we write this equation y into x equal to I? This equation number 1 we can rewrite as y. Now this entire matrix minus 2, 0, 3, 1 I am taking as x. So can I write this y times x equal to I? Now this equation I am going to multiply by x inverse on both the sides. So I'll get y x multiplied by x inverse equal to I into x inverse. Then this x into x inverse should give me I. Okay, so y into I will be equal to, and this I into x inverse will be give me x inverse. So I get this equation. And ultimately y into I is nothing but y. So y will be equal to x inverse. So I am getting y is equal to x inverse. And we are supposed to find out y in this question. So y will be nothing but x inverse. So what is x? That we know. So x is given to us as minus 2, 0, 3 and 1. Now just find out x inverse, that will be our y. Okay, so to find out that, we'll find out first the determinant of x, which will be equal to minus 2 minus a 0. Okay, which is nothing but minus 2. Now let us find out the adjoint of this x. Okay, adjoint of the x will be nothing but 1 and minus 2, 0 and a minus 3 over here. This is the adjoint. So your x inverse will be nothing but 1 upon determinant of x, that is minus 2, times the adjoint of this x, which is 1, 0, minus 3 and a minus 2. Now this is your x inverse, and your x inverse is nothing but your y. So can you say that y is equal to minus 1 upon 2 times 1, 0, minus 3, minus 2. This is the answer for your question number 17. Now let us verify the answer from the back of the book. And back of the book, the answer given is minus 1 upon 2 times 1, 0, minus 3, minus 2, which is absolutely correct. Okay, so that was our question number 17. And now quickly let us move on to question number 18. Question number 18 is if matrix 2 minus 3, 0, 1 plus x, the matrix x is equal to 1, 0, 0, 1. Okay, find x. Now this is very simple. This is an equation given to you. So this is a addition of matrices. So here, if you want to find out x, okay, what you should do, first of all, let me tell you, this matrix minus this matrix 2 minus 3, 0, 1 is a 2 by 2 matrix. Agreed? So if there is a 2 by 2 matrix, then if you add something and if you get 1001, that means this something has to be other 2 by 2 matrix. Okay, so let this matrix elements be A, B, C and D. Okay, Okay, now this is 2 by 2 identity matrix. Okay, now if you work out this, so you'll get 2 plus A equal to 1. This 2 plus A equal to 1. And if you work out this 0 plus C equal to 0, so 0 plus C equal to 0, and you will get this 1 plus D, 1 plus D equal to 1, and you will get this minus 3 plus B, this minus 3 plus B equal to 0. Okay, so from this, one thing is clear, that C will be equal to 0. That is clear from here. From here, what is clear? B is equal to 3. That is clear. Okay, B is equal to 3. Now A and D you want. Okay, so from here you will get A is equal to 1 minus 2. That is minus 1. And from here D I will get 1 minus 1, 0. Okay, so I got all the elements of this X. Okay, so this X, which was A, B, C, D, that I'm getting now as X is equal to, I'll just put in the value of A, B, C, D. So A is minus 1, B is 3, C is 0, and D is also 0. So this is the answer for this X. Okay, so the question was find X if from this equation. So let us check the answer behind. So for question number 18, the answer is minus 1 and a 3, and then 0 and minus 3. There's a minus 3 over here. D should be minus 3. Okay, now there is some mistake over here. The matrix is, okay, this is not 0. By mistake I had okay, it is a 0. 2 minus 3, 0 and a 1 plus X equal to 1, 0, 0 and 1. Find X. Okay, 2 minus 3, 0 and a 1 plus A, B, C, D equal to 1, 0, 0, 1. Fine. Now D we want. Okay, so 1 plus D equal to 1. Yeah, so 1 plus D should be equal to 1. So D will be equal to 0. D has to be 0. Okay, so I don't know, but answer behind, it is given here for D, it is given as uh, minus 3 somehow, but I have verified it, and I'm getting D is equal to 0. Okay, so this question number 18, the answer behind the book, it is given as X is equal to minus 1, 3, 0 and a minus 3. Okay, so there is some ambiguity in this answer. According to me, the answer is this. Okay, minus 1, 3, 0 and 0. But behind the book, the answer given is minus 1, 3, 0 and a minus 3. This we will have to just check it. So this question number 18, I am doubtful about this question number 18. So let us see what can be done about it. So I think that's all for this today's lecture. Or let me try to complete one more question. Let us complete two more. So let us go to question number 19. Okay. Question number 19 says that find B if A is a 2, minus 2, minus 1 and a 3, and AB is equal to 4, minus 2, 0 and a 7. Okay, now here B you have to find out if A is given to you and AB is given to you. Okay, so let us do one thing. AB is given to us as 4, minus 2, 0 and 7. Now this A is given to us as 2, minus 2, minus 1 and 3. This is your A. And this is your B. Now B, let it be A, B, C, D. The elements, let it be A, B, C, D. This will be equal to 4, minus 2, 0 and then 7. Isn't it? Now let us do this multiplication. So on the left hand side, what I will get is, on the left hand side, I should get first row, first column, that is 2a minus 2c. Then first row, second column, I'll get 2b minus 2d. And second row, first column, that is this multiplied by this, should give me minus a plus 3c. And here I should get minus b and plus 3d. Okay, so this is my left hand side. Okay, this should be equal to 4 minus 2, 0 and 7. Okay, see, we are asked to find out this b. Okay, so b is nothing but this one, right? A B C D. Okay, so now what I will do is I'll equate this two. So I'll get minus a plus 3c equal to 0. 3c will be equal to a. Okay, this is what I'm getting, 3c equal to a, right? Now from here what I'm getting is 2a minus 2c is equal to 4. Okay, so that is what I'm getting from here. Now here using this 2, okay, let us try to find out if we can find out something. So this is 2a minus 2 into, here c can be written as a upon 3, isn't it? C can be written as a upon 3. So here instead of this c I am going to write a upon 3. This is equal to 4. Now from here I can get this a. Okay, so what I will do is 3 2s are 6a minus 2a upon a 3 will be equal to 4. So 6a minus 2a is 4a equal to 3 4s are 12. So a will be equal to 12 upon 4, that will be 3. So I am getting a equal to 3. Okay, now let us try to find out the remaining things. Okay, so once you get a equal to 3, I'll get c also. C will be equal to 3 upon 3. So c will be equal to 1. Okay, so I'm getting c equal to 1, I'm getting a equal to 3. Now what is remaining? B and D. Okay, let us try to do this. This will be 2b minus 2d equal to minus 2. Okay, now here this what can be done is okay, now here also I'm getting this minus b plus 3d is equal to 7. Okay, now what can be done is okay, these two equations I can solve simultaneously. Okay, these two equations I can solve simultaneously to get b and d both together. Okay, so what I will do is this one I'm going to multiply by 2. So the first equation is 2b minus 2d equal to minus 2. This can be written as b minus d equal to minus 1. Okay, and this equation, and instead of multiplying this by 2, I'm going to keep it as it is. Okay, so this equation, the second equation will be minus b plus a 3d is equal to 7. Okay, now these two equations, if I add them up, okay, if I add them up, b minus b is 0. This is minus d plus 3d will be 2d. This will be minus 1 plus 7 will be 6. So d I am getting 6 upon 2, which is equal to 3. Okay, so once I get this d, I can find out b also. So b I can get it from here. So b will be equal to uh, uh, minus 1 plus a d. So b will be equal to minus 1 plus d, just now I got as 3. So b will be equal to 2. Okay, so I got all a b c d. So by matrix what they had asked you to find out, b. Okay, so my matrix b, which was a b c d, will be equal to, I'll plug in the values, so it will be 3 and then 2 and then 1 and then 3. So this should be the answer for my question number 19. So let us verify and check whether the answer is correct. So for 19th, the answer is 3, 2, 1 and 3, which is absolutely correct. And let us do one more question, question number 20. And this question number 20 is saying that if 3 minus 3 and 2 and a 5 multiplied by, no, it is not multiplied, minus a x is equal to 1001. You have to find out x. Now this is a simple addition of matrices. Okay, so here if you rewrite this equation, 3 minus 3, 2 and a 5, and this if you bring on this side, so this will become minus 1, sorry, minus 1 0 0 1. This minus x will come on this side, so this will become x. Okay, now all I have to do is subtract these two matrices. So 3 minus 1 will be 2, minus 3 minus 0 will be minus 3, 2 minus 0 will be 2, and 5 minus 1 will be 4. This has to be my matrix X. So let us check the answer behind for question number 20, and the answer is 2 minus 3, 2 and a 4. So this is also correct. Okay, so we have completed till question number 20 from exercise 2, and this video I'm going to end here and here itself because time doesn't permit me to go ahead. And in the next video I'll be continuing from question number 21, and I will try to complete the exercise because it has some 28 questions in all. Okay, let me check whether there are more or not. No, there are 28 questions in all. So 8 more questions are remaining in this exercise, which I may try to complete in the next video. So till then, goodbye, good luck all of you. See you all.